US Physics Olympiad year 2018 final round USAPHO. This examination consists of two parts. Part A has 3 questions and is allowed 90 minutes. Part B also has 3 questions and is allowed 90 minutes. Problem A1. Question A. Suppose you drop a block of mass m vertically onto a fixed ramp with angle theta with a coefficient of static and kinetic friction μ. The block is dropped in such a way that it does not rotate after colliding with the ramp. Throughout this problem, assume the time of the collision is neglectable. First, suppose the block's speed just before it hits the ramp is v and the block slides down the ramp immediately after impact. What is the speed of the block right after the collision? Second, what is the minimum μ such that the speed of the block right after the collision is 0? Question B. Now suppose you drop a sphere with mass m, radius r and the moment of inertia beta m r square vertically onto the same fixed ramp such that it reached the ramp with the speed v. First, suppose the sphere immediately begins to roll without slipping. What is the new speed of the sphere in this case? Second, what is the minimum coefficient of friction such that the sphere rolls without slipping immediately after the collision? Solutions for problem A1. Part A. During the collision, the block receives impulses from the normal force, friction and gravity. Since the collision is very short, the impulse due to gravity is neglectable. Let Pn and Pf be the magnitudes of the impulses from the normal force and the friction force. Since the block stays on the ramp after the collision, its final momentum is parallel to the ramp. Then the normal force must completely eliminate the block's initial momentum perpendicular to the ramp. So we have Pn equal mv cosine theta. Since the block still moves after the collision, we have Pf equal mu Pn or mu mv cosine theta. The block's initial momentum parallel to ramp is mv sine theta. So we have mu equal mv sine theta minus mu mv cosine theta, or velocity equal v multiplied by sine theta minus mu cosine theta. Second, we have to set u equal 0. It means that mu equal tangent theta. Note that this is simply the no-slip condition for a block resting on an inclined plane. This is because in both cases equality is achieved when the normal force and maximal friction force sum to a purely vertical force. Question B. Now suppose you drop a sphere with mass m, radius r and the moment of inertia beta m r square vertically onto the same fixed ramp such that it reached the ramp with the speed v. I. Suppose the sphere immediately begins to roll without slipping. What is the new speed of the sphere in this case? Here, because we have no slipping after impact, we have angular momentum conservation around the point of contact. It means that initial angular momentum, which is mvr sine theta, equal final angular momentum, which is m multiplied by moment of inertia around this point, which is beta m r square plus r square due to parallel axis theorem, multiplied by omega, which is angular velocity of rotation. And because we don't have slipping, we have omega equal Vx over r. From here we can find what is horizontal speed of the sphere, Vx, which is v sine theta over 1 plus beta. Second, what is the minimum coefficient of friction such that the sphere rolls without slipping immediately after the collision? As in part A, because we have a change of normal impulse is mv cosine theta, and the change of horizontal momentum is mu multiplied by p normal, we have f horizontal equal mu mv cosine theta. But from other hand, that's equal to initial horizontal momentum minus a final horizontal momentum, which is this expression, or change of horizontal momentum equal mv beta sine theta over 1 plus beta. Using this equation and this equation, we can find what is minimum possible coefficient of friction. That will be beta tangent theta over 1 plus beta. That was a solution for problem A1.